Hi, I thought I would make you a video that had the solutions for numbers 9 through 12 from the step-by-step problems from Mr. Stu Schwartz. We thank him very much for these excellent problems. And I thought instead of writing key here, I would write my name, Mr. McGrath. That's me. Okay, so let's get started. Here's a function. F of x is equal to e, remember that's just a number, plus natural log x over x squared. And part A says find the average rate of change. Average rate of change is an actual slope. And I don't know, maybe I don't want to mislead you by saying actual slope. What I mean is we're actually going to use 2 points, right? From here to here. So all we need to do here is plug in 1 into this function. So let's see, e plus the natural log of 1 is 0. So on the top would be e plus 0 over 1 squared. That's e over 1 squared, or just e. And the other point is the point e, comma. Let's see what we get here. That would be e plus the natural log of e. That's what do you have to raise e to get e? That would be 1. It would be e plus 1 on the top. And the bottom would have e squared. So e plus 1 over e squared. Okay, and now we just find slope. So looks like it'll be a little bit messy, but I can handle that. So that's y minus y over x minus x. Now, I don't know about you, but that offends my sensibility of what counts as simplified or not. So I'm going to simplify that by first getting rid of that denominator and multiply the top and the bottom by e squared. I'll get rid of that. So let's see, distributing this here gives me e plus 1 minus e cubed over e cubed minus e squared. And that looks a little better to me. All right, we don't have the fraction in fraction in fraction. Okay, write an equation of the tangent line to f at x equals 1. Well, at x equals 1, we've already got the point. We did that in part A. 1 comma e. So we need slope. And to find slope, we have to take the derivative of this. So let's see, f prime of x would be equal to, using the quotient rule, low, d high. Remember, e is just a number, so the derivative of e is 0, times the derivative of natural log x is 1 over x. That's low d high, minus high d low over low low. And you can go ahead and simplify that if you want to. I think I will, because I'm that kind of guy. So let's see, that's x squared is 1 over x. That's just x minus, I don't think there's any great benefit in simplifying this, in distributing, that is, over x to the 4th. I think I'm going to leave it like that. So we need a slope at 1. So let's see, f prime of 1 would be equal to, I'll leave myself much room here, 1 minus 2 times 1 is 2, this e plus the natural log of 1 is 0, so that's e over 1 to the 4th is 1, so 1 minus 2e. So it looks like my slope is 1 minus 2e. So the equation for the line in point slope form is y minus equals the slope times x minus x. There's the line. Crazy looking line with all those e's in it, but that is the equation for a line. All right. Find the x-coordinate of the point on f at which the tangent line is horizontal. Well, the tangent line is horizontal when the derivative is equal to 0, right? And I've got the derivative right here. And since it's a fraction, we can write out the whole thing if we want to. X minus 2x e plus natural log of x over x to the fourth equals 0. Of course, the only way a fraction can be equal to 0 is if the top is equal to 0. That turns into x minus 2x. There's e plus natural log x equals 0. Now that is a tricky little equation to solve. Let's see if we can do it. I'm going to factor an x out. That's x times 1 minus 2 times e plus natural log x equals 0. Notice that x equals 0 does give me 0 here, but we can't, that's not one of our solutions, because looking back here, remember when we said only the top has to be equal to 0? Of course, 0 over 0 is not equal to 0, and x equals 0 makes both the top and the bottom equal to 0. So that's no good. That does not help. We need to make this equal to 0. So let's see if we can do that. Trying to solve that for x now. So let's see, I've got 1 minus 2e. I'm going to distribute this now. Minus 2 natural log x equals 0. Trying to solve for that. So let's see, that'd be 1 minus 2e equals 2 natural log x, or natural log x is equal to 1 minus 2e over 2. So that means that x would be equal to e to that power. That's e to the 1 minus 2e over 2 power. That's crazy, but that's what it is. And we could confirm that, right? We could actually graph this and find where the tangent line's horizontal and find that it's equal to that value. And be a good exercise with your calculator to do that. Okay, last part. We want to find the limit as x approaches 0 from the positive side of this function and as x approaches infinity. So let me just write down so I don't have to slide up and down here. Our function was f of x is equal to e plus natural log of x over x squared. And we want to know, like, as x approaches 0 from the positive side. They have to say positive side because you know as well as I do the domain of the natural log function is only the stuff. Remember what the natural log function looks like. Draw a little picture of it here. It looks like this. It does not exist down here. So they have to say from the positive side because it does not exist below 0. So let's try plugging in 0, see what happens. If you plug in 0, you get e plus negative infinity over 0. Well, can we make any sense of that? This means a huge negative number, I mean e minus infinity, might as well be minus infinity, divided by a tiny number. And dividing by tiny positive numbers just makes things bigger. So this is going to negative infinity, right? We just have to reason through that, really. This is negative infinity on top, right? If you try to plug in 0, as you get closer and closer to 0 on the natural log function, you're plunging down toward negative infinity. And dividing by a tiny, tiny number, that makes things even bigger again. So going to negative infinity there. Now let's try to plug in infinity and see what happens. That gives me e plus the natural log of infinity is infinity, although it goes pretty slowly to infinity, over infinity squared is infinity. Well, that's an infinity over infinity, and yay, we just learned L'Hopital's rule. We get to use it. So it's an infinity over infinity. So let's take the derivative of the top and the bottom. So that didn't work. And we say that the limit as x approaches infinity of e plus natural log x for x squared is equal to the derivative of the top. The derivative of e, that's just a number, is 0. The derivative of the top is 1 over x. The derivative of the bottom is 2x. Now we try plugging in the infinity. We get 1 over infinity is 0 over 2 times infinity is infinity. That's 0 over infinity. That's not indeterminate. 0 over infinity, 0 over huge number, is 0. So L'Hopital's rule worked for us there. All right. That was fun. Okay, let's try this one. Let f of x be this function. F of x equals the natural log of x plus 1 over x. And they want in part A, show that this is the derivative. Well, that should be pretty easy. We've got the answer here. We just have to get it. So let's see if we can do it. F prime of x is equal to the derivative of natural log of whatever is 1 over whatever times the derivative of what's inside. The derivative of x is 1, and the derivative of x to the negative 1 is minus x to the negative 2. Should be that. Now we just have to make that look like this. Alright, so let's see if we can do a little bit of algebra here. To simplify this part here, I'll multiply this fraction by x over x, and that'll get rid of this denominator here. So that gives me x on the top and x squared plus 1 on the bottom. Okay, and then for this part here, I'll get a common denominator. 1, I could write that as x squared over x squared. 1 is the same as x squared over x squared. So x squared minus 1 over x squared is my common denominator. And then, let's see, we'll simplify that. I've got an x and an x squared here, so that can cancel with one of those. And on the top I've got x squared minus 1. And distributing that x through here, I get what we were looking for. That might, remember, these are supposed to be like free response questions from the real AP test. They do ask questions like this where you just have to show something and you know what you're shooting for. So that's not unlikely. You really might see something like that. Okay, find the x-coordinate of the point or points on F where the tangent line is horizontal. Well, we just talked about this, right? That means where f prime of x is equal to 0. And even if you failed part A, you already know, they told you what the derivative is, right? It's right here, so you just set that equal to 0. And that happens when the top is equal to 0. And that happens at x is equal to plus or minus 1. Now we just have to check and make sure that neither one of those answers gives us also a 0 on the bottom. So we'll try 1. That gives 1 plus 1, so that's okay. No 0 on the bottom. And negative 1 cubed is negative 1, plus negative 1 would be negative 2. So they both work. That was easy. Find the equation of the tangent line to f of x at x equals 2. To do that, I need a point and a slope. The point would be 2, comma, whatever I get when I plug 2 in here. So it would be the natural log of 2 plus 1/2, or the natural log of 2.5, or the natural log of, I think we prefer improper fractions. And that's our point, 2 comma natural log of 5/2. And the slope is, that slope is whatever we get when we plug 2 into the derivative, and that's right here. So that'd be 2 squared minus 1 is 3 over 2 cubed is 8 plus 2 is 10. So 3/10 looks like. And now we can write it. So y minus y is equal to m times x minus x. Come on, how awesome is point-slope form? No work. All you need is the point and the slope, and you can write your line. Okay, now we've got a new function, g of x, which is defined to be e to the 2 times f of x. They want us to find g prime of 2. Alright, well let's see. G of x is equal to e to the 2 times f of x, which is this. That's the natural log of x plus 1 over x. In all sorts of ways, on the real AP test, they're going to work in little things to figure out if you know your pre-calculus. And this is that type of question. This is really to see if you know your exponent rules and about logarithms and stuff like that. So first thing you need to recognize is this can go up here. That's one of our logarithm rules, is an exponent here can move to the front, and likewise this can move up here. Why would you want to do that? Because you should know that if you have e to the natural log of something, those two things are inverse operations. They cancel each other out. Example, think about this for a second. Right over in the margin here. You had e to the natural log of 2. Well, what is the natural log of 2? The natural log of 2, by definition, is the exponent that you have to raise e to get 2. This, a logarithm, natural log of 2, is the exponent you have to raise e to get 2. Well, what happens if you raise e to that power? You get 2, by definition, right? So it's very similar to this. What's the natural log of e squared? 2, right? These two things are inverse operations. They cancel each other out. They undo each other. So here we've got that situation. So that's just x plus 1 over x squared. So now we've got a reasonable form for that for the g function. So g prime of x is equal to 2 times x, I'm using the power rule here, plus 1 over x to the first times the derivative of what's inside, which is 1. Derivative of 1 over x is minus 1 over x squared. And finally, g prime of 2, plugging 2 into this, we get 2 times 2 plus a half is 5 halves times, oh, there's our ladybug friend again. Hello. The 1 minus 1 over 2 squared. So let's see, that's 5 times 3/4, 15/4. Whoop. There it is. All right. That was a good exercise in pre-calculus stuff. Now they want us to show that f of x and g of x have horizontal tangent lines at the same x values. Well, we already found the x values for this, so all we have to do is show that the g, we have to show where is g prime of x equal to 0. And we have g prime of x right here. It's 2 times x plus 1 over x times 1 minus 1 over x squared. We have to set that equal to 0. Well, it's this whole product is equal to 0 when this is 0 or this is 0. So just like as if it were like x minus 2 and x plus 2, right? We set each factor equal to 0. So let's see. Where is x plus 1 over x equal to 0. Let's see. Multiplying through here by x would give me x squared plus 1 equals 0. And, well, that's not going to happen, right? No solution. Looking back at this, you could say, like, if x was positive, this would also be positive, so that can't get you to 0. And if this was negative, that'd also be negative. That's not going to get you to 0. So we're not getting any solutions from that side. So we look here. So 1 minus 1 over x squared is equal to 0. It's the same as saying 1 equals 1 over x squared. Cross multiply. That's the same as x squared equals 1. And sure enough, that's true when x is plus or minus 1, right? And that's the same answer as part B, right? So indeed, they have horizontal tangent lines at the same x values. All right, that video is 21 minutes long, so I'm going to cut that there and do a separate video for numbers 11 and 12. That was numbers 9 and 10.